Hello everyone, let us discuss our topic on permutation groups. Introduction to permutation groups. Permutation groups are a fundamental concept in mathematics. They involve the study of rearranging elements in a set. The study of permutation group has been application in the various areas of mathematics. Definition of permutation groups. A permutation group is a group that consists of all the possible permutations of a set. The set of all the permutation forms a group of under composition. The identity element in a permutation group is the identity permutation. An example of the permutation group is the symmetric group of n elements denoted as Sn. Sn consists of all the permutations of n elements. The order of Sn is n factorial. Properties of permutation groups. Permutation groups are closed under the composition. Every permutation group contains an identity permutation. Inverse of the permutation in a group is also known as a permutation in the group. Cycle notation in permutation groups. Cycle notation is a compact way to represent the permutation. A cycle notation consists of disjoint cycles. For example, 1, 2, 3, 4, 5 represents a permutation that maps to 1 to 2, 2 to 3, 3 to 1, 4 to 5, and 5 to 4. Transpositions in permutation groups. A transposition in a permutation that swaps two elements and leaves all other elements fixed. Any permutation can be expressed as a composition of transpositions. Transpositions are the fundamental building blocks in the permutation groups. Orbit and stabilizer in permutation groups. In permutation groups, the orbit of an element is the set of elements it can be mapped to under permutation. The stabilizer of an element is the set of all permutations that fix the element. The orbit stabilizer theorem relates the size of the orbit and the stabilizer of an element. Group actions. Group actions are a way to formalize how a group acts as on the set. Permutation group naturally arises as a group acting on a set. Grouping actions provide a geometric interpretations of a group theory. Conjugacy in permutation groups. Conjugacy is permutation group is a equivalence relation. Two permutations are conjugate if they are related by a similarity transformation. Conjugacy classes partition the elements of a permutation group. Applications of permutation groups. Permutation groups are used in the cryptography for encryption and decryption. They play a crucial role in the combinatorics, particularly in counting and enumeration problems. Permutation groups have the classification in the computer science, group theory, and algebra. Symmetric group and alternating group. The symmetric group is the group of all the permutation of n elements. The alternating group An is the subgroup of even permutations in Sn. An is a normal group subgroup of Sn and Sn by An is the isomorphic to the cyclic group of order 2. Permutation representations. Permutation representations are a way to study the group actions through permutations. Every group actions give rise to the permutation representation. Permutation represents help us to understand the structure of groups. Permutation group algorithms. There are efficient algorithms for computing with permutation groups. One such algorithm is the algorithm for computing a base and the storm generating set. These algorithms are essential in computational group theory and permutation group analysis. Permutations. Order matters, repetition allowed. Possibilities equals n power r. Order matters, repetition not allowed. Possibilities equals n factorial by n minus r factorial. Combinations. Order doesn't matter, repetition allowed. Possibilities n factorial by r factorial of n minus r factorial. Order doesn't matter, repetition not allowed. Possibilities n plus r minus 1 factorial by r factorial of n minus 1 factorial. Future directions in permutation groups. Research in permutation group continues to explore new structure and applications. Advances in computational methods are expanding the study of large permutation groups. Future directions may include applications in machine learning, quantum computing, and cryptography. Permutation and combinations. Number of permutations of n things taken are at a time. P of n r equals n factorial by n minus r factorial. Number of combinations of n things taken are at a time. C of n from r equals n factorial by n minus r factorial into r factorial. Number of different permutations of n objects where there are n1 repetition items, n2 repeated items till nk repeated items is n factorial by n1 factorial, n2 factorial till nk factorial. We come to the conclusion of this topic. Permutation groups are a rich area of study in the mathematics with diverse applications. They provide a framework for understanding symmetric group actions and combinatorial structures. The study of permutation groups continues to be a vibrant field with connections to the various branches of mathematics.